Hello!
Oh.
Hey, you're worried? You're dangerous?
I learned my lesson last time.
Okay, no.
Yeah.
So we're back.
We are back.
Gabriel and Ale. Okay, this GoingNative, we don't have the cool background. We got poor all of a sudden. You're in your office.
I am.
Jeez,
That's right.
This whiteboard is a little bit dirty, man.
Yeah, it's often utilized and rarely cleaned.
Right. We built a very beautiful C++ tree with a lot of goodies. It's almost, the holidays.
Exactly.
It's great.
Yeah.
So we have a great, talk that we are going to show you soon. We just talked actually, this morning, or just now in a certain sense, with Tanveer Gani.
Tanveer Gani.
From the FrontEnd compiler, right?
That's right.
Was it interesting? It's
Yeah.
pretty cool, yeah.
That's my second time meeting him. I shadowed him earlier for another project. So.
Oh, that's true, that's true.
So that was he's good people.
He's great, nice, yeah, nice guy. I've been working with him for a bunch of time. He's been here for a long time. So, without much further ado, let's go in the interview, and then we see each other in the Destructor. Great.
Let's do it.
Hello everybody, we are here GoingNative again. Gabriel is behind the camera, you don't see him. You don't see me, I'm Ale Contenti, and we are here with the front-end dev. Tanveer Gani has been in the front-end for the longest time, worked with Tanveer for a long time, was the dev lead of the front-end, did a lot of features together, yes. That's great. So Tanveer, yes, can you present yourself?
My name is Tanveer Gani. I've been a dev in the front-end team for 15 years now.
Wow, congratulations.
Well, not quite 15, this is my 15th year.
Yes.
So a long time. I have a lot of time to learn the ins and outs of the front end, and led the team for 4 or 5 years there in the middle, which was again an exciting time for us. But now I'm back to regular dev role, just day-to-day development.
Hacking the code, lots of code.
Try not to do hacking,
yes,
hacking of the sense that just put in hacks, but definitely try to stick to good engineering principles.
Yes, absolutely.
Yes.
So you've been working lately. You've been working actually, on the rejuvenation of the front end. What we call it. Can you tell us more about that?
Yes. The front end, as most everyone knows, is extremely old. I think the oldest comment I have noticed in it dates from 1982.
Wow.
I actually had an intern see that comment, and he was shocked by the date on the comment, given that he was born in 1984, I think.
The comment.
Yeah, he's younger than the comment, the code. And that was several years ago, actually. So the code is definitely, it is a creature of its time. It was meant to save on memory, the way it's structured. So use as little memory as possible, because back in those days that was very precious. The machines were way slower than they are today. So it's a lot of optimization done with those things and restrictions in mind. Now, obviously, we can afford a whole lot more, and we are trying to modernize the source so that it can actually do many more things than it previously could. And of course, the way the code was written was also not very amenable to easy extensions, and understanding obviously took a while to achieve because of the way it was written.
We really did a lot of things along the history of the compiler.
Yes, but along the way we have been slowly updating and modernizing it and sort of modularizing it.
Yeah.
But now we are doing things that are more ambitious. We are structuring it so that it is sort of more phase-based, where we would do things through successive refinement in it, and where it would be able to achieve many more things than it currently can, which is simply compilation.
Yeah, exactly. Do you have some examples of the things you are thinking of, or some features?
Yeah, so actually one of the things that we have not been able to implement is two-phase lookup. And this is something that people have noted and have complained about, and we have had to say, sorry, you can't do it yet because the infrastructure is not in place to do it. And but we are moving in the direction where we can implement that at some point in the future once the infrastructure is in place. That practically requires being able to parse at a high level and then bind things as we parse. But currently we tokenize, and then we don't really know that things that are currently defined. Later on, we just instantiate and reparse the tokens, and the way it's done right now, it just doesn't work for two-phase lookup.
Yeah.
So that's just an example. There are other things like that we are currently doing, like const expert, for example. That did require infrastructure change in the compiler. So I previously alluded to the memory optimizations. One of the things that we would typically do in the compiler is that we would build trees only up to the expression level and emit them as soon as we could. That way we were not hanging on to trees in the compiler, not consuming memory, and we could reuse memory.
So basically we build a tree, we emit some IL code,
right away.
Then we throw it.
We emit the IL2 files that the backend reads on later pass.
Right.
So we are not hanging on to memory for long. Basically just the life of the expression. This makes it extremely memory efficient, but this also prevents us from doing multiple passes over the trees that would allow us to do much more.
Yeah, sometimes we lower the tree too much.
Yeah, the tree is always lowered completely to the point where you could generate code out of them. So the trees, again, were very back-end oriented. They were ready for the back-end to consume and generate code from. That loses a lot of the high-level aspect of the language. For example, we will normalize all field accesses, whether it be an arrow or a dot operator, to the arrow. Because that's what the backend likes. It likes to see field accesses in that format. But that loses the information whether the user actually wrote a dot p or a arrow p.
And it's not that the backend devs are very far away, just 2 doors down, right?
Yeah, they're just right there.
Well, yes. When we change the IL, we just tell them.
Yes, no, we can still. The thing is not that we want them to change. The thing is that we want to preserve the original form of the trees in the front end, and then we will actually lower it down to what the backend wants.
Right.
Now this requires us to preserve trees, and that, of course, we consumes memory, but we can afford memory now. There's a lot more available now. This is part of the rejuvenation effort. We are actually raising the level of the trees from these extremely low level backend things up to where they better match the language.
And you're also preserving the trees alive.
Yes, now one of the first things we have to do, for example, for const expert implementation is we have to preserve all the trees in the function. We can't just build them up and emit code right out. That doesn't work anymore.
And so that's what shipped in the November CTP that we just shipped.
The partial const expert implementation we did, which includes scalar types and reference the pointers scalar types, but not class literal types or array literal types. Use exactly that.
So if you could open up the front end, you will see the trees for the
function. They're all there. They're still in flux in that we are actually still raising the trees up in terms of semantics.
And they are not yet exposed to the customer. So
no,
the customer doesn't have a way to see these trees.
Right.
For the moment.
We have not gotten the point yet where we will say, well, here are the ASTs, the front-end generators, and you can go consume them and write, plugins, say, on top of them. We're not at that point.
Thinking about
that, yes, but that's definitely the track we are taking here.
Yeah, nice. Yeah. So was it painful? Was it a lot of work to do const expert? Was it?
You would think it would not be that much work if you already had ASTs, but the fact that you didn't have any, and we had actually put in a lot of scaffolding just to get the point where we can evaluate those trees, turned out to be a lot of work. But from what I hear, const expert is a lot of work for everyone. Regardless of the modernity of your front end.
That's a great achievement to have trees back and so on.
Yes, definitely. This is the classical compiler that we're talking about. Like I said, we didn't have that based on historical reasons, but those reasons are mostly disappeared now. So we are actually moving towards a better structured, more modern compiler now. And
can you go in some details now? How we build these trees, or where do they come? They come from the grammar, or they come from something else?
Again, that's the part of the problem that normally, and if you basically get somebody fresh out of college and tell them, go write me compiler that generates trees, they will write a grammar, say, and the trees will all get basically structured and constructed in the grammar. As the grammar rules are reduced, you basically end up generating these trees. That's not the way our parser works, unfortunately. It does that for expressions, does not do that for anything else. So it has this habit of basically generating an expression, then calling an action saying just emit this tree out.
Yes.
And the challenge is to basically mutate that into something that is generating larger and larger sets of trees, covering more and more of the language. So we have lots of techniques that we are exploring, and some that have worked for us that we are basically
So you
using.
basically try something and it doesn't work.
No, we actually, the constraint we have is that we don't want to go dark and be off in a branch for 2 years or whatever, and then come out with the nice front-end generating trees. We really want to keep shipping. We want to stay honest. We want to basically incorporate this work in the shipping compiler, so it gets continuous benefit from it, rather than keeping compiler static for 2 years and then suddenly it becomes better.
Yeah, one of the great value of the compiler that builds so much code, right?
Right.
In Microsoft and out there in the world.
Really don't want to get into a situation where we do a lot of work and then we basically have to do another lot of work to recover back to our quality level, where we are building NT, we're building Office, we're building SQL.
And all the code
the code out there. Right? These are basically our internal validation criteria that we got to build NT correctly. And it should, you should build it, it should boot, it should run stress tests. Right? You don't want to break that.
And we go back to that test over and
over. That's basically our sort of quality criterion that we use for any compiler that we send out there.
And a bunch of conformance suites.
Yeah, of course, that goes without saying. I mean, but it's actually interesting that even though you will pass all conformance suites that are commercially available, that our QA have internally written, that our devs have written as unit tests, you can still break NT and Office because you cannot possibly cover all the source that's out there.
So much. So
that's why it's very useful to have these giant code bases that have any number of permutations of C++ features in them. And once we compile that, our confidence level is high that it's a good compiler we're going to put out.
Nice, that's amazing. Yeah, cool. I mean, I don't know if you have some other detail. I also want to say that Tanveer is one of the front-end devs, and we'll try to go and talk with a bunch of front-end devs because we feel that we are putting a bunch of energy in the front end, the rejuvenation, the new C++
definitely with
the 14
with the C++ standards tracking, all the work that we're doing. That's only something that other devs can speak to.
And then many they've been working with Tanveer for a while, like John Caves, for example, or Mark Hall. But some new guys have been starting to
Yes, we added
play and learn the
few people on our team recently, and they're doing great work. Helping us to catch up with Conformance faster.
So we try to go around and talk with more of them. For example, you did the first part of ConstExpert. That's one.
It's still going on.
Which one is the first feature you did when you joined 15 years ago? Do you still remember?
I was actually, the day I joined, I was assigned 25 bugs to fix, and they all were in DeclSpec deprecated. That's basically a DeclSpec or extension for VC that we put on things we don't want users to use anymore. And, or you would do that, say, in your header file if you didn't want someone to call an API anymore. And there were so many bugs in it. I got assigned 25 the first day, and of course I had to work through them, and then I worked on the old IntelliSense engine for a while.
Of course.
Yes, the thing again.
What was the DLL name called?
It was called FEACP.dll. It was much reviled and hated, and rightly so, because it was limited by its nature. It just could not keep up with all the features of C++ kept adding.
It was part of basically the same source code of the batch.
Yeah, it was basically the same batch front end, except was heavily if-def. It was surgery plus heuristics, and it worked to a degree, but then it hit the end of the road where it just could not anymore.
Right.
But that was one of the first things I worked on, and
wow.
then I transitioned into, actually we were doing the 7.1 release, which is a heavy conformance release, and I think the first conformance feature I implemented there was argument dependent lookup.
Oh, wow.
Yeah, so
Wow.
there was
The Koenig.
a Koenig lookup, as it used to be known
wow.
back then.
Sweet.
Plus other things, because it was a lot of conformance work, was a lot of grunt work trying to get the heavy template libraries back then, Boost and Blitz, those were the big ones back then, to compile correctly.
And then we redid our STL after.
Right.
Yes.
Right. So
Oh, sweet. That's a bunch of features under your.
yes, I'm happy to see the old FECP DLL gone. Of course, as
Yes.
a lot of people know, we actually redid the IntelliSense engine
Yes.
a few years back.
Yeah.
It was first shipped in VS 2010.
2010. Yes.
Right.
So.
And just as an anecdote, we could not use the old IntelliSense engine on our own FE sources.
All right.
It just would not work. It just was not capable of handling our source complexity.
Topple over. Right.
But the new one is just fine.
Yes.
We
And
just
you get squiggles and you get a lot.
yes,
Much more
and
performance.
we basically we use that tool. I would like to put a plug for that. It's not something that this team would, but the ID team, I think, the project. It's called PDB Project.
Oh yes, that's true. Yes.
If you don't know about it, you should know about it. And basically, what it allows you to do is, if you have say a project that builds, it could even be a makefile project, right? If your source is so complicated that you don't have a VS project for it, or whatever reason, you can have a makefile project as long as there's a PDB be available. You can point at a PDB and it will generate a VS project for you. Then you can use it to develop. And you
get IntelliSense.
You get IntelliSense.
Code navigation.
I don't know whether you can build with it though, but you can definitely get IntelliSense.
Yes.
Code
Then
navigation,
you can
IntelliSense.
click and,
Yes.
and add your build line if
It's
you want.
very fast and very user friendly. It takes about 5 minutes to set it up.
Yeah, and then the benefits you get from code navigation and squiggles.
Oh yes, I
Go to
mean
definition
squiggles. Actually, it's a funny story about squiggles. We first thought about them way back in even FECP days, and I attempted to implement them because VS was doing for C#, and then we gave up after like a couple weeks on it because FECP just could not give us the fidelity we required.
Right.
So it had lots of false positives, lots of heuristics in it. It just could not give us squiggles. So we gave up on it for a while. Then when we did VS 2010, again we proposed it. I actually did a prototype very early on, and that worked just fine. But then we cut it due to we don't have enough resources for 2010. Let's do it in a future release. But then we were forced to do it because we realized that we would have to parse imperfect code. And our parser is a full compiler actually in IntelliSense engine. It's full C++ compiler.
It's based on the EDG.
It's based on the EDG front end, as a lot of people know. And we did not want to put in a lot of heuristics there to allow it to recover from errors that were just too bad. Let's say you had a class and you did not declare a member function in it, and you actually defined a member function out of line.
Yeah.
Now, FECP would handle it just fine because it would bend over backwards to somehow put that member function back in the class. And we could do that with EDG, but we did not want to start doing that because then that ends up messing up the source code too much, and the merge conflicts that happen when EDG updates the source and so on. And it turned out the squiggles were the right choice there. So now, instead of us attempting to somehow put the member function in the class, we just have a squiggle there saying, well, this wasn't declared. And it's so easy for user to go fix it.
And it's a visual indication. That's why when I press dot, I don't get anything.
Right, and it actually tells you at the bottom the thing was available. And then eventually you see the squiggle. So that was the reason we actually brought squiggles back. It was a good feedback mechanism for users to tell them that you did something wrong. That's why you're not getting IntelliSense. But then it turned out that people started relying on it to verify their source, whether it was correct, right? And then the bar was raised, right? It went way up. And then we had to basically say that, well, we can't have false positives in the squiggle because that confuses users. We can have a false negative, they can be missing error, but not a false positive.
I agree.
And it's gotten, I mean, I'm happy with it. It's gotten good enough that in the front end, if I don't have squiggles in the sources, it'll just compile fine.
I agree with you, yes.
Yeah,
It's a feature that is very, you kind of don't notice it, but
yes.
you know, you kind of, your brain is kind of processing, oh, well, you know, I still have a few squiggles, let me finish up before I press F7 or whatever.
Right, definitely doesn't enhance your productivity.
Yeah, it's very interesting, you know, it comes under you, you don't even feel that it's there, right? You know, it's sweet. It's nice.
Of course, we still on the watch for false positives. So there's those, you know, definitely do report.
And we go. Of course, we want to shoot for full fidelity eventually, right? So that's what we'll think about always, right? Well, that's
yes, one of the things that we are still thinking about there is that we actually in templates we don't report squiggles. It's because each squiggle there actually requires a whole context stack. The error could actually be somewhere else, not in the template. But reporting it there doesn't have currently a good mechanism in VS to, you know, bubble that up or expose that somehow. Because you really need to step back through all the instantiations to where the actual error is, which could be n levels up. So unfortunately, that's something we didn't do or couldn't do, and now we're still thinking about like what's a good way to actually do that.
Yes, if you have suggestions, comments is your place, right?
Yeah, those actually would be the ID guys would actually be more interested in that.
Just redirect to
definitely,
yes. Absolutely, yes. Okay, well, there was a great chat.
So happy to do that.
Yeah, we should talk with Tanveer more often. Well, for us, I guess, you know, do you have anything to add? You know.
No, but you know, just want to tell our users out there that we definitely do, you know, pay attention to everything they tell us. You know, and are trying our best currently to work on Conformance, put out a great compiler. You know, provide lots of features.
I know. No, that's great. You know, I think also the November CTP, the one with November in 2013, just last month, that we shipped was, you know, and a very nice set of features. You know, show that there's good progress from also the VS 2013 RTM.
Right, that's meant to give users a glimpse into what's happening with the team and give them a sense of what's coming down the line.
There's also a weight there, not only C++ 11, 14 conformance features. So if you haven't, please do try it out. Send feedback, connect, blog, email.
Yes, one of the reasons we put out a CTP is that so we get feedback, you know, bug reports,
anything,
suggestions, whatever. Definitely do send them our way.
Yes. Squirrels bringing bugs, whatever. Yes, anything you want. Cool. Huh? Yes. So you know we are filming this December. So you know, happy holidays to everybody.
That's happy holidays.
Yes. We see each other soon.
Yeah, and a happy New Year as well.
Yeah, happy New Year and happy everything. Yes. Okay, and write more code during the vacation, right? You know.
Yes, for sure.
Okay, great. Bye. So, it was a great interview. Did you like it?
I did.
What did you like the most?
I think definitely when we talked about PDB projects, I think it's great when people in previous episodes for GoingNative and people in future episodes, they talk about the same thing and what they like, and really encourage you guys to go check out the extension if you haven't used it already, and
nice,
feedback.
Nice. Yes, and plus I really like the history about the front end, the old things we did, and then we did it another way. How intelligence worked before, how intelligence work now, and just how the compiler is. It's working, and how we are making it better.
Seen it all.
And so there's always feedback for every feature we are doing. Go download the November CTP, give us feedback about that. There's a bunch of C++ 11, 14 features. We are working on more, as you see. We are working on the inner side of the compiler to make it more robust, better ASTs for every function for the entire compiler. So, well, that's great. I'm excited. We'll talk, like we say, we talk with more front-end people. We have a good list to go through. And we try to talk with a lot of people that go native code. That's what we are about.
Yes.
So have a native holidays, do whatever you do, write a lot of code, use the CTP, send us all those little games, those little utilities, large projects, small project.
Provide us feedback.
Great. Bye.